Hello and welcome. In this video, we are going to talk about multi-tenancy. We'll go over the basics of multi-tenancy. How does multi-tenancy compare to other forms of architecture for SaaS, such as single-tenant, as well as virtualization? Then we'll discuss how do you scale an application in a multi-tenant environment. We'll cover the database architecture options for multi-tenancy, and then we'll sum up the tutorial going over the advantages of multi-tenant as well as some of the advantages of single-tenant applications. What is multi-tenancy? Multi-tenancy is a SaaS architecture in which multiple tenants use single instance of software, and that single instance includes everything: application, configuration, hardware, operating system, everything. If you do not understand what SaaS means, we recommend that you watch our tutorial on SaaS. It stands for Software as a Service. At a high level, how does the logic for the application work to make sure that all the different customers or the tenants can use the same instance? That lies in the application code. Based on your login ID, be it an identifier or an email or your phone number, the code is able to identify which customer you belong to, or alternatively, what's your user ID, who are you. Code will be able to identify that. Now, how does that mapping work? It could be based on at the time of your sign up, let's say in a B2C environment, or alternatively, it could be mapped in the backend when the customer that you belong to, as an example, if you belong to Google and you're an employee of Google and you're using a certain software, your ID may already be mapped somewhere within the database or an application settings screen. Alternatively, it could be based on your domain name. So if Google signed up as a customer for a certain software vendor, then your email ID, as an example, at google.com, might be enough for the application code to identify you. Now let's go over single-tenant. Single-tenant is a form of SaaS architecture in which every tenant, unlike multi-tenant, has its own instance of application, software, hardware, configuration, operating system, everything. And then we have a somewhat unique approach to SaaS architecture in the form of virtualization. Virtualization, as some of you may already know, is the technique of creating virtual images of software instances. So it may be a way, sort of approach in SaaS to achieve single tenancy, while in the true sense, those customers would not be having their own instances in terms of their hardware and environments. We are not going to cover virtualization as a technique in detail here. We recommend that you look it up online or alternatively watch one of our other tutorials. Now, how does scaling work in multi-tenancy? As you can imagine, if a software vendor has thousands of customers and hundreds of thousands or millions of associated users, at some point they cannot just host their software on a single server. So there are two approaches to scaling. One is vertical scaling. So as an example, if you have an application server or a database server that has got a certain computing power in terms of gigahertz capacity or a certain amount of RAM, that you can scale it up vertically, increase that capacity, but that has its limits. Beyond a certain point, you cannot have like millions and millions of gigabytes, as an example, in terms of RAM. So what do you do in that case? You do horizontal scaling. So you start adding more servers. Now, in its most simplistic definition, what are you going to do? You can add more application servers which are running the application code, and then you can add more database servers which are hosting your database. Now, scaling the application server is slightly easier. In fact, a lot of the cloud computing providers like AWS provide auto scaling services where your application server could be scaled up or down based on your traffic. But scaling database servers can be slightly a lot more complex, and that is something we are going to discuss in the next few screens in this tutorial. Now, as discussed on the last screen, horizontal scaling for databases can be trickier. Now, why do you need horizontal scaling? Think of a situation, your database is hosted on a server, and at a certain point, the server would just give up. Either the hardware server or the database management software, be it Oracle, SQL, MySQL, anything, because beyond a certain point, they cannot handle more than few thousand concurrent connections. So what do you need to do in that case? You need to scale. Here are a few options that are typically used for scaling databases. You could use replication. So as an example, you could have different read copies of the database. So your main database, as an example, could be in New York, where everything is getting written to, but then you could have read copies of that database in Washington, in Johannesburg, anywhere. So people who are just reading from the application or from the database don't have to hit your main database. But then you could have, but in those situations, if someone is reading, as an example, from Johannesburg, to be able to make the write, there's still that synchronization and latency. How do you get around it? You could do a multi-master approach, where essentially all the databases that you have in different locations have write ability, and then there's synchronization going on between them. Then you have a partitioning approach, where essentially if your database has tons of tables, say 10,000 tables, you could put 5,000 of those tables on one server, another 5,000 on a different server, and that helps you achieve better performance. And then the third approach is sharding, which is kind of different from partitioning in the way that while partitioning is more focused on separating the tables out or spreading them out over different servers, sharding splits the tables horizontally. So if a table has like billions of rows, you could split it horizontally, put X amount of rows on one server and then different other set of rows on a different server. While this is a complex topic and needs sort of research on its own, we would recommend that you look it up online. The good news is that a lot of these offerings are now sort of being offered out of the box by providers such as AWS. So as an example, with AWS Aurora Global, some of these functionalities could be easily implementing without you having to do a lot of the work yourself. Now let's spend some time taking a look at the database architecture options for multi-tenancy. We mentioned earlier that for the application code based on your login, the system can figure out who you are, and then based on that, you might have access to a certain kind of application functionality and so on. But then, based on your privilege, you also have access to your own data. But then, how is that data stored? There are multiple options. Option one, all the tenants would share the same schema. So data for all the tenants is stored in the same set of tables. And how does the application figure out what data you have access to? There's a customer ID that's associated with every customer or tenant. And based on that, the SQL statements and the application code will give you access to only that data. This option may have its drawbacks because there's a possibility where if the code is not properly written, one customer may see another customer's data. However, truth be told, the way applications have been implemented in today's day and age, it does not happen a whole lot. The second approach is separate schemas in a single database. So every tenant could have their own copies of all the tables. So if there's one customer, customer A, they might have their own table, their own set of tables for location, for user data, for their billing and payments and so on. And customer B would have the same set of tables to store their own data. Then the third option is every tenant has its own separate database. And this is kind of popular amongst the companies or industries where you may be concerned about other vendors or other software customers having access to your data. Think of healthcare, think of banking. Each of those approaches have their own pros and cons. The second approach is kind of sort of a win-win situation, uh, a sort of a more balanced approach between those two approaches. But based on the requirements of the industry and of the customers who are signing up, the software vendor might implement or propose either of these approaches. Now let's go over the advantages of multi-tenant and single-tenant. Before we go into this, the advantages listed here are not the overall advantages of SaaS software. We are not going to cover those here because they apply to both multi-tenant as well as single-tenant. Those advantages have been covered in detail in our SaaS tutorial. So what are a couple of obvious advantages of multi-tenant? There's going to be lower ongoing costs to the customers because they are sharing the resources. And then there is the ease of maintenance for the customers because the vendor can take care of it a lot more easily. And there are lower costs to the vendor as well. So generally would be part of sort of a broader maintenance schedule where the vendor is going to take care of everyone's upgrades, bug fixes in a single go. Now let's take a look at the advantages of single tenant. While a single tenant application might be more expensive to the customer, there are some obvious advantages to it. The performance would be better because you have your own hardware, your own environment. The security would be a lot better because you are storing your data in your separate databases, in your separate servers. So there's absolutely no chance of external access by other customers. You have better control over the upgrades. While with the multi-tenant, all the customers would typically get the upgrades within same schedule, something they might not prefer in terms of downtimes. That generally does not happen with single tenant. And then customizations, because you have your own environment, you would typically be able to do more customization to the software compared to multi-tenant software. So that sums up this tutorial. Thanks for watching this video. If you have any feedback or suggestions, please put that in the comment section of the video or alternatively submit your feedback at launchpad.com. Thank you.